Okay, this is example 3 from lesson 1.1. We can do that later, okay, bud? We can do that later. Awesome. So everybody has their notebook out. Thank you to all the people who are ready with a pencil in their hand. This is still lesson 1.1, example 3. This is where it's starting to get a little bit wordy. Does anybody ever look at a word problem and just go, I don't know how to do it, and you barely even read it? That's how I feel sometimes. I look at a word problem and it scares me. And I automatically think I don't understand it. But then I go, wait, well, maybe I should read it first. And then I read it first, and then I still don't understand it. So I have to read it again. And then I start to understand it a little bit more, and sometimes I might draw a picture of what it's saying, and that helps me understand it a little bit more. And a lot of times you want to underline or circle really important information. Just no noise over there, okay? Really important information. So before we start doing all of that, let's read it. Can somebody read it out loud, nice and slow, so we can kind of soak it in? Go ahead.
A lab technician needs 25 liters of a solution that is 15% acid for a certain experiment. But she has only a solution that is 10% acid and a solution that is 30% acid. How many liters of the 10% acid and the 30% solutions should she mix to get what she needs?
That's a lot of information, right? You did a great job reading it. It's a lot of information. Some of the information is not important. Like a lab technician. I don't really care who the person is. It can just say a person. So that's not something I would need to underline. That's just kind of telling the story. What's the first thing that you see that's going to be really important information for our problem?
Liters.
Yeah, and we want to also include the value, right?
Yeah.
25 liters. I might also underline that she needs 25 liters. Okay. What's next? What's more? It doesn't have to be perfect. Just what other girls? Okay. What other parts are really important?
The percentage.
Exactly, because the 25 liters of the solution needs to be 15% acid. If it's not 15% acid, her experiment won't work. But unfortunately, she only has a jug of solution. We don't know how many liters it has, but we have some sort of jug of solution that is 10% acid. And then there's another jug of solution that's 30% acid. So she needs a total of 25, I'm just gonna put this in like a little science speaker, okay? She needs 25 liters, whoops, 25 liters, that's 15%. And she has two other solutions. We're going to make some sort of combination, a little of this and a little of that. Some sort of combination of this one that's 10% acid, and this one, my jugs, my beakers are just ridiculous, okay? So terrible drawing, but we got, we're just working it out. Okay, so we've got one solution that's 10%. The other solution is 30% acid. And don't you wish it was like cooking where you could just like add a little of this one and add a little of this one, taste it and see if it is the right balance. You want the balance of 15% acid, but we can't really do that with a science experiment, right? We might burn our tongues or taste really bad. So you can't just figure it out by if it looks right. You can't figure it out by if it tastes right. You have to figure it out mathematically. Okay, so do you guys agree that there's going to be an amount of this plus an amount of this solution to equal this 25 liters? Since we don't know how much of this solution, and we don't know how much of this solution we need, we have two missing numbers, we have two variables. Do you remember when we had a problem that was nothing like this, but hear me out? We had a problem that said, what 3 consecutive integers added up to blah, blah, blah. We were missing 3 numbers. So did we call those 3 missing numbers X, Y, and Z? No. We assigned a variable to one of them. Then we represented the other ones by using that same variable. Can we do that with this? Let's call the 10% solution X, okay? Just like when we did our 3 consecutive integers, we called the first one X, okay. So if our 10% solution is X amount of liters, X number of liters, we don't know how many liters it is, but let's just for fun, just take like a wild guess. Give it any amount of liters you think it might
60.
be. How much?
60.
60?
Yeah.
So we need a total of 25 liters. So give me any amount that might work. Just a guess.
Oh, let's see.
12, sure. Now we're just guessing, okay? We're not at this isn't actually the right answer, but we're just guessing. Let's say this number is 12. How can we use X, 12, to represent this solution in liters? 12 is part of it. The 12 and the other amount of liters has to add up to 25. Yes?
It's 12 plus 1, so x plus 1 is 13, and 12 plus 13 is 25.
Okay, you are totally right, but x plus 1, now, since this is just a guess, okay, I'm gonna use that, okay? You said this would have to be 13 liters, right? If they have to add up to 25, you said this would have to be 13, right? We're just making up numbers, we're just guessing, we're not actually doing any crazy thing here. So I'm gonna ask you more questions, okay? If these have to add up to 25, which they do, how can I represent this 13 by using x? Now, it can't be x plus 1 because what if this solution is 10 and the other one is 15? That would add up to 25, but then it would be x plus 5. We need something that's going to work for everything. Now keep in mind that x plus this has to equal 25. Let me do it like this. 25 equals x. Let me do like a baby equation, okay? Forget about that. Let's do 6 equals x plus. Do I want to do baby equation? Okay, I'm not gonna go there because I think it's gonna be too much of a variation. Okay, so let me ask you this way: using the total 25 and this missing value x, how can we represent the rest of the liters? This represents some of the liters. This represents the rest of the liters that we need. How can we use 25 and x in an expression to represent the rest of the liters that we need? Everybody get it?
Can't quite put my finger on it.
Okay. Okay, I am gonna make baby equations. Let me just say we need 10 liters, okay? And then let's say, I need some over here, and then let's just say the rest is 4, okay? Let's say, okay, good. How do you write an equation using, or an expression, using the 10, the total, and the x to get 4? You said x is 6, which is correct. How do you use 10 and x to get 4?
Correct.
Subtract what?
Yeah.
The total
Yeah.
minus your x value, and that will get you the rest.
Oh.
So, right, it's a little crazy, but that's why baby equations help smaller numbers, okay? So if this represents some certain amount, this amount will have to be whatever this is subtracted from the total. You got it?
Yeah.
So this would be 25 minus x, which represents the rest of it. Are you guys with me on that?
No.
Yes. I'm making my.
Who is it now?
Hold on.
Okay. Would it help if I went back to this real quick? The only thing we're worrying about right now, I don't even care about the acid right now. I don't care about the acid. I don't care about trying to get 15% of anything. I don't care about this 10% and I don't care about this 30%. All I'm talking about is the liters. This has to be 25 liters. So that means these two, however much we use of each one, it has to add up to 25. Exactly. So we're gonna represent, so we have two missing numbers. Just like when we had consecutive integers, x, and then x plus 1, and x plus 2, they all represented the values, but we used x to represent the values, so when we solve, we only have one variable, okay? So, if this represents some missing amount of liters, like 2, or 20, or 9, anything, the rest of them would be here. So you would just take whatever this number of liters is, subtract it from 25 to get the rest. So take your x number of liters here, take it away from 20, take it away from the total, and this, for now, will represent our value. It's not a number value, we don't know what it is yet, but at least we have a way to represent the other number of liters. Kind of. It's hard. It's okay. It's okay. For these kinds of problems, for some of you, it might not click the first time. That's why we're recording and you can watch it over and over. Sometimes with me, if I read a word problem that I feel like I'm not understanding, I just have to let it go and try it again another time. And it's okay if you're feeling overwhelmed. Just try to follow along. If it's still overwhelming, watch the video later when you like have a cup of tea and like nobody's making noises in the back. That would be helpful. If everybody's not making noises in the back, turn around please. Thank you. All right. So for now, let's just agree that we need a total of 25 liters. That's the goal. And we need to have some sort of combination of this solution and this solution. So we have a total of 25 liters. We have X amount of liters, and we have whatever that value is subtracted from 25 to get the rest of the liters. Now here, look at what the book has here. They rewrote this, and some of it's gonna look confusing. I'm going to work that part out, okay? So we're all still taking notes. Even if it's something that the book wrote, if I'm writing on it or pointing to it saying, yes, this is good, you write that down too, okay? So again, we are talking about the total of what she needs equals this part plus this part. And I'm going to explain what this all means. You agree that the total is 25 liters. She needs 25 liters. So 25 liters of what? 25 liters of something that's 15% acid. So 25 liters of a 15% acid solution. That's just writing it out in words. Then we're gonna simplify it and say, okay, well, 25 liters of 15%, what does of mean in math?
Division.
Multiplication. So this of really is a multiplication sign. And I know, I said not to use x as a multiplication sign, but in this case, I'm just writing over the word of. 25 liters times 15% is how we're going to represent that. Can we do math with a percentage, or do we need to convert it?
You can do it with percentage.
Is it easier to convert it to a decimal or a fraction? Especially when you type it into a calculator. It's easier to convert it to a decimal or a fraction. Here, we'll just convert it to a decimal, which will be really simple to type into a calculator. By the way, if anybody wants to use a calculator and you don't want to use your EOC calculator, just take one and pass it along, okay? If you don't want it, just pass it, okay? But this needs to be silent so everybody's paying attention. All right, here we go. 25 times 15%. 15% as a decimal is what? 15% as a decimal.
0.15.
Thank you, 0.15. 0.15 times 25. Can somebody tell me what property we used? And the book just did this because they felt like it. 25, you could definitely write this as 25 times 0.15, and that would be beautiful. The book decided to flippy flip, and it's okay because they're using the commutative property of multiplication because they liked the way this looked better, and that's fine. I just want to explain why this flipped to that, and that's okay. Now, here's where we use our trusty little calculators and give our brains a break. We type in 0.15 times 25, and we get 3.75. So that is going to represent the 25 liters of 15% solution. We simplified that part. One part down, 2 to go, okay? Now let's go to our 10% solution, which we are just calling X number of liters, okay? X number of liters because we don't know how many liters we need to pour yet. So we'll just say a missing number amount of liters represented by the variable X, which eventually we will solve for. Do you want to help?
Yeah.
Okay. So X number of liters of the 10% solution, what does of mean again?
Multiplication.
Multiplication. Multiply, okay? So, this is terrible. I have an X variable. I can't use an X as my multiplication sign. I'll just go like this. I'll put in parentheses. X number of liters times 10% solution.
Give x 10.
Yep, X times 0.10, right?
I know.
And then they also, again, use commutative property of multiplication to write 0.10x, which actually makes sense, right? Usually our variables are on the right, even though both of them are correct. So x times 0.10 is simply 0.10x. Now they simplified that just a little bit further. What did they do to simplify that? All they did was take away the zero. Are we allowed to remove zeros?
Yes.
Yeah, we can remove zeros as long as they're on the right side of the decimal and there are no more numbers involved. So yeah, that zero doesn't need to be there. So this is going to be represented by 0.1x. 2/3 of the way there. Now we got this crazy looking one because we don't know what this one is either. And we couldn't represent it with a different variable because then we wouldn't be able to solve. But we used the relationship of these two. to give it a value including a missing number, okay? So this value is still represented by 25 minus x. It is a number that we will solve for. 25 minus x, number of liters. Okay, that sounds weird. 25 minus x number of liters.
Yeah.
Okay? 25 minus x number of liters of, what does that mean? Multiplied by 30%.
Knock it off.
What is 30% as a decimal?
0.3.
0.3 or 0.30?
Zero.
Yep. And look, they used commutative again. Why do you think they used commutative here?
Because
They want to do another property. Because they want to distribute, and I love it. So they just flipped these, commutative property of multiplication, and now we're going to distribute our 0.3 to our 25 and our negative x. And if you want to use your calculator, that's fine. 25 times 0.3 equals 7.5. Oh, I forgot to draw my arrows. I'm just going to draw them underneath. Boop. Boop. What is really important about this x? This x is negative. So make sure you include that negative when you are multiplying. 0.3 times negative x is?
Negative 0.3x.
Yeah, negative 0.3x. So that's all we, that is all we can do to represent this amount right now. They can't be combined, right, because they're not like terms. At least they can't be combined with each other, but maybe we can combine them with something else. Okay. So let's go over what we have. We have 3.75 equals 0.1 times x plus 7.5 minus 0.3 times x. Yes, it looks complicated, but it's a complicated situation. Remember, these kinds of questions answer the common question from students that says, when will we ever need to know this? And you're probably thinking, but I don't want to be a lab technician, so I won't have this. Maybe you'll be something else that you didn't expect, and you'll need to know how to solve these kinds of situations. Instead of being like, a little of this, a little of that, and I'll just hope that it's 15%, we need to know how to use these. Okay, let's keep going. Let's keep going. We have 3.75 equals 0.1x plus 7.5 minus 0.3x. I'm going to rewrite that over here. Can you guys see if I do this? 3.75 equals 0.1x plus 7.5 minus 0.3x. I'll put minus 0.3. Minus 0.3x. Can we solve this equation? We've been solving the things that look just like this the past couple of days.
Wait.
3.75 equals 0.1x plus 7.5 minus 0.3x. Guys, there are decimals involved here. That's what these beautiful things are for. Because what we're focusing on is more the concept rather than, do you know how to add decimal numbers? You already learned that, you've mastered it, so we're gonna let our calculator do the hard work, okay? We're gonna solve this just like we would with regular whole numbers. And we're gonna use the calculator to work out the decimal portions, okay? But what do we do first? It starts with a C.
commutative property.
Nope, a different C. Combine, finish that, combine.
Like term.
Like terms, very good. What should I do before I look for my like terms? Hey, what's a like, what should I do? What should I do?
Variables.
Circle each term with its
Positive, negative type stuff.
yeah, we want to include the variables if it has a variable.
Yeah.
But the term includes the
It's
variable.
integer.
We want to circle each term with its,
Decimal.
you said a word.
Integer.
Yeah, what makes it an integer is it could either be positive or negative,
Oh,
right?
yeah.
Okay, so we want to circle it with its
Like it.
sign. This one doesn't have a sign, so it's
Positive.
good. This one has a sign, the signs are always to the left.
Positive.
And this one, even though I drew the sign super tiny,
It's
it
negative.
does have a sign, it's negative.
Yes.
Okay. Now, what do you see that can be combined? Remember, combining means adding them together. What can be combined? Anybody? Yes.
Point.
1x and
Take a gander.
Yep, and negative here. And guys, you can type negatives into your calculator if you want.
How?
Remember, we're combining them.
No
So you would do 0.1 plus, we're combining. And then to put a negative 0.3 in your calculator, you do 0.3, and then click that bottom button that has a positive, negative symbol. It's right next to the equal sign. If you click on that, you'll see that your 0.3 shows up as negative. Press your equal sign and you get what? Negative 0.2. Good.
Plus.
I'm going to cross these out because I'm done with them because they became a negative 0.2. Can I combine this with anything else?
No.
No. Plus 7.5 equals 3.75. Whoops. Oh my gosh, I forgot my X there.
Holy smokes.
Whew, that was a close one. All right, what do I do next?
Add.
you
Add
subtract
what?
7.5.
Yes. Subtract 7.5 on both sides. And guys, cancel, and then use your calculator again. It's so easy, right? We just do 3.75 minus 7.5. Oh no, it's a negative number. That's okay.
Yes, go.
Negative 3.75 equals negative 0.2x. Last step.
Division.
Division is correct. X is being multiplied times negative 0.2. We divide by negative 0.2. Or negative 0.2, same thing. Cancel, divide by, same thing on the other side, negative 0.2. Calculators. Now for me, I'm not gonna type in my negatives because I know a negative divided by a negative is just gonna be a positive. So I'll just do 3.75 divided by 0.2, and I get 18.75 equals X. Is that the answer that they asked for? It says, how many liters of the 10% and the 30% solution should be mixed? What does the X represent? The 10%, very good. So our 10% solution, the 10% solution will be 18.75. Raise your hand before you shout out the answer. How do we find the other solution, the 30%? Go ahead. I didn't even say anything. I was about to throw it to you.
You do 25 minus 18.5.
Yes, that is correct. Because we look and see, well, the 30% solution is 25 minus X. If X is 18.75, do 25 minus 18.75, and we get 6.25, yes. So the 30% solution is 6.25.
You're being loud. Knock it off.
Oh, which part, Jayla? So the way that I got this, sorry, that was one step that I didn't write out. I took my X value, which is what we called the 10% solution. And so that's how many liters, I should write liters, 18.75 liters is how much we need. But that's just the 10%. To find out the rest, we have to use our 25 minus X. So we take our X value, the 18.75, we plug it in here, and then we do 25 minus the 18.75 to get the rest. And guess what, guys? Get out your calculators. Add these together. See if it equals 25 liters. I sure hope it does.
It does.
It does? Okay, good. Then we did it right. We are not done. If you can get this problem on your first try, I will give you a Jolly Rancher.
Oh my God. Wait, what? You just did that.
We just did it, but this time they need 30 liters total. 30 liters total. And they need an amount, they need 30 liters of 25%. And they want to know how many of the same 10%, okay? So the same 10% plus the 30%. Now, I'll give you a hint, okay? Is it going to be x and 25 minus x? It's going to be x and 30 minus x. You guys got it. Try to solve it. Figure out what it is. You got a few minutes. If you get it right on your very first try, it's not a race. I'll give out multiple Jolly Ranchers if there are many people who get it. This was a really bad percentage. Okay. And you have your notes to look back on if you need to, okay? What? Yes.